In numbers 12, 13, and 14, it looks like we have some absolute value questions. Again, you're trying to isolate the absolute value, and then you can deal with it. So first I'm going to deal with this divided by 2. The way that I do that is I multiply both sides by 2, multiply u by 2, multiply u by 2. These 2's will cross-cancel, leaving behind the absolute value of k. That's going to be equal to 4 times 2, which is 8. And now I can deal with the absolute value. The way that I deal with that is this is going to turn into 2 separate equations. The first equation, you just drop the absolute value and say k is equal to 8. And then the second equation, you drop the absolute value and you say it's equal to the negative version of the right side, which is negative 8. And we're done. These do get a little bit more complicated. All right, and number 13, again, isolate the absolute value. So we're going to get rid of this 8 and the 7. Some people mistakenly think the 8 and 7 get subtracted, and you say, oh, well, that's just 1. That's not correct because the 7 is being multiplied by all of this. So you need to first get rid of the 8 by subtracting the 8 and then divide by this negative 7. So minus 8 first. That's going to be negative 7 times the absolute value of r over 10, and the absolute value is equal to a negative 7. And then finally here, to get the absolute value by itself, divide by negative 7, divide by negative 7. These will cross-cancel, leaving behind just the absolute value of r over 10, and the right side is going to be 1. Now we can deal with the absolute value. This is going to turn into 2 separate equations. First is r over 10 is equal to 1. The second equation is r over 10 is equal to negative 1. And then from here, we're going to solve both of these the same way. We're going to multiply both sides by 10. Multiply this by 10 and 10 as well. 10 and 10 cross cancel, leaving behind r is equal to a 10 and then r is equal to a negative 10, both of which are your final answers. In number 14, a little bit more complex. Again, we need to get rid of this 8 and this 5. We undo the subtraction first, or undo with the subtraction first. I'm going to subtract 8, and we get 5 times the absolute value of negative 1 minus 3a, and absolute value is equal to 5, and then divide both sides by 5, divide by 5, divide by 5, and the absolute value of negative 1 minus 3a is equal to 1. From here, you're going to separate this into 2 equations. The first equation, drop the absolute value symbol, and we get negative 1 minus 3a. That's going to be equal to 1, and then drop the absolute value and get negative 1 minus 3a. That's equal to negative 1. From here, we're going to solve each of these the exact same way. Add 1 to both sides. And that's going to be negative 3a is equal to 2, or negative 3a is equal to 0. And then divide by negative 3. So we'll say here, divide by negative 3, divide by negative 3 on all of these. And you are done, leaving a is equal to negative 2/3, and a is equal to 0. All right, number 15. These are inequalities for 15, 16, 17. The way that we deal with inequalities, these are not compound inequalities, they're just simple inequalities. Just move variables one side, move non-variables to the other. I'm seeing that I have an x on this side and constants that need to be moved over. I'm going to first simplify. What is 3 minus 5? This is really negative 4 is less than or equal to 2x minus 2, because plus 3 minus 5 is minus 2. And then finally, I'm going to move it over. I'm going to add 2, get negative 2 is less than or equal to 2x. And I'm going to divide both sides by 2 to isolate the x, divide by 2, and x over here, and then on the left side is going to be negative 1. So just remember that this is the same thing. These can go backwards or forwards. If I switch the sides, x and negative 1, then I also switch the sign. This used to be a less than or equal to. I'm going to switch it to a greater than or equal to. I typically like having the x on the left-hand side so I can read this. I read from the left to the right. So I say x is greater than or equal to negative 1. If I were to read this backwards, I would say x is greater than or equal to negative 1. Because we read left to the right, this symbol is a greater than or equal to. You can also say that negative 1 is less than or equal to x if you want to read it that way. So I'm going to go ahead and plot negative 1. I am able to be equal to it, so this can be a closed point at negative 1. So closed point as opposed to an open point. And then if it's greater than negative 1, I'm going to the right of negative 1. So those are the 2 pieces you need. You need the graph and you need the inequality. Number 16 is going to be the same way, except I'm going to have some distribution in here. This 4 times 4 is a 16. This 4 times a 7x is a positive 28x. I still have a plus 6. I still have this inequality symbol and 106. I'm going to combine the 6 and the 16. That's going to become 22 plus 28x. Recopy that down. I still have this greater than symbol and 106. And then from here, I'm going to subtract 22, getting this variable 28x on the left by itself. So I have this greater than or equal to symbol. And I'm going to have, what is this going to be? Minus 22. I'm trying this new trick, and it's not working right now. If I add 8 to this, it's 114, so it's 84, is that right? 84, yeah. Mind blanked for there for a sec. So 84, and then from there, I'm going to divide everything by 28, divide by 28, divide by 28, and then from there, there's an X, that symbol. Okay, this symbol only switches whenever we multiply or divide by negative. I'm dividing, which makes me cautious. Subtracting and adding doesn't do anything, but whenever you divide, you're cautious. This was a positive, so I don't have to worry about it. 84 divided by 28. I'm not sure. 3? I think so. Let me just double check. 28 times 3, is that equal to 84? 3 times 8 is 4. 2 times 3 is 6. 7, 8. 84, yeah, okay. So that must be 3. So again, I'm going to switch this around. So X is on the left and 3 is on the right. Whenever I switch the sides, I also switch the sign. So this is X is less than 3. So I'm having an open point at 3 as opposed to a closed point. This had an equal to sign. This one does not have an equal to sign. And this says less than 3. So I'm going to go to the left of that 3. All right, so I have my inequality and I have my graph boxed. I guess I don't really graph or box the graph. All right, lots of distribution coming out over here. 8 times 1 is 8. 8 times negative 3a is negative 24a. Positive 5 times a 7a is a positive 35a. 5 times 2 is a positive 10. We have a greater than or equal to negative 48. Let's combine some like terms. I see a negative 24a and a positive 35a. That looks like it's going to be an 11a. And I also see that we have this 8 and this 10 adds up to an 18. Still greater than or equal to negative 48. And from there, I'm going to get rid of 18 by subtracting 18 on both sides. That's going to leave me with an 11a is greater than or equal to both the same sign, so I'm going to add. It's going to be 60, 8 and 8, 16, so 66. Negative, of course, and then finally we're going to divide everything by 11, divide by 11, divide by 11. Oop. So just remember, if you're dividing, always check if you're dividing by a negative. Oh, we're dividing by a positive, so I don't have to worry about it. I don't have to change the sign. You only change the sign when you multiply or divide by a negative. From here, we get a by itself, and that's going to be greater than or equal to negative 6. And notice the variable's on the left, so we don't have to switch the sides. Greater than or equal to negative 6 means I have a solid point at negative 6, and greater than means I'm going to the right. All right, number 18. Now we have compound inequalities, which means we need to solve each individual piece and then use the keyword here, or versus and. I'll explain the difference here in a sec. So first I'm going to get rid of the 1. I'm going to say subtract 1, and m is going to be less than or equal to negative 6. And I'm done with that one. Over here I'm going to subtract 6, and then I'm going to get m is greater than 4. And this is combined with the word or. So let me graph both of these on an intermediate graph, and then we'll graph the final solution up here. So intermediate graph, we're going to say we have a point here that can be a closed point at negative 6, and a closed point here, it's not a closed point, it's an open point. I apologize. Like an open point at 4. This one has an equal to sign, therefore a closed point. This one has no equal to sign, therefore open point. 4 is on the right because 4 is positive, negative 6 on the left because negative is on the left. So from here, this is saying that we're to the left of negative 6. So to the left of negative 6 is like that. And this is saying m is greater than 4, so I'm to the right of that 4. And this keyword or means wherever there's one line. So or means one line. There's one line everywhere there. So essentially this is the final answer. I didn't have to do any additional work, and I can just come up here and say negative 6 and to the left, and 4 open point to the right. And number 19, I'm sure we're going to have to do something a little bit different. I don't know what that is there. All right, let's go ahead and solve. Let's go ahead and subtract 2. I'm going to do it down here. Subtract 2, 9n is going to be greater than or equal to negative 45. That's an n. And then I'm going to divide by 9, n is now greater than or equal to negative 5. Subtract 2, n is going to be less than or equal to 7. Let's do an intermediate graph, and then we'll do the final graph. This one didn't really need it, but you always want to check. So here's my graph. I have a spot here at negative 5 and a spot here at 7. This one's going to be a closed point. This one's going to be in another closed point. They're both equal to. They have equal to in them, right? This one says greater than negative 5, so I'm going to be going to the right of negative 5. And this one is saying less than 7, which means I'm going to the left of 7, like this. And the word and means you need all lines. And since we have 2 equations, all lines would be 2 lines. So this means where we have 2 lines. Well, I only have 2 lines, not here, but here. This is all the area that I have 2 lines, and then I go back to having 1 line. So the answer is strictly between -5 and 7. Do we include -5 and 7? Yes, because these are close points. So my final answer is going to look like this. I'm going to make a close point up here at -5, a close point at 7, and anything in between here is an answer, which means -4 is an answer, -1 is an answer, 1.3951 is an answer. Anything that is in between there, including -5 and including 7, is an answer. So there's our graph. All right. Oh yeah, I guess we need to do the inequality notation for those, don't I? So here's the inequality notation. You don't do anything differently. Over here, you do have to have a slightly different notation. You want to say that x, or it's n in this case, n is in between those 2 values. The way that we say in between is we do it like this. These have equal to signs because we were equal to those points. And we want to say between -5 and 7, so we just put between -5 and 7. As long as you're always having less thans and less thans on both of these, then you always go from the smallest value to the largest value, which matches your number line up here. So I can go ahead and box that inequality notation. Number 20, again, I'm going to be solving. Let's go ahead and subtract 5. Ooh, that's not what I want to do first. Here, I'll tell you what I want to do. What I want to do is I want to get rid of the 2x. I'm going to add 2x to both sides, add 2x to both sides, gone and gone, and then I'm left with 5 is less than or equal to 7. And that's it. This is kind of a weird statement. There's no more x's. Let me ask you guys a question. Is 5 less than or equal to 7? Yes or no? Yeah, I would say yes. 5 is less than or equal to 7. It happens to be just strictly less than, which is fine. So the answer here is yes. And more specifically, always. Oh, I cannot spell. It's always yes, which means I'm going to get rid of that and make the math answer all solutions. No matter what, 5 is always less than -7, less than or equal to -7. So the answer is all solutions. The graph for this one looks like this. There's 5, there's 7, and the answer, it doesn't matter. It's everything. You don't even need to bother doing this inequality over here, because if you're doing an or only cares about 1 line or more. You could have 1, 2, or 3. Anytime you have at least 1 line, that's the answer. And since I have 1 line everywhere, the answer is everywhere. It's all solutions. Sometimes we have a shortcut for this. We say R for all solutions like that. You can say all solutions or R, but the graph of it is a line that just goes everywhere. In number 21, we have an absolute value inequality. So again, the trick is we want to get rid of everything except for the absolute value. This +6 is going to go away. So -6. I want to do that down a little bit. So I have room -6, and I get absolute value of a over 6 is now strictly greater than 1. And then I'm going to turn this into 2 different equations now that I've isolated the absolute value. This is going to be a over 6 and a over 6 after we drop the absolute value. One of them is going to be greater than 1 because you just drop it and leave it. This other one, I'm going to flip the sign, change that to a negative. Essentially, everything on the outside of the absolute value got multiplied by a -1. And this is going to be less than a -1. And we're kind of done. I'm going to go ahead and do an intermediate graph down here to see what's... Oh, we're not done. I still have to multiply by 6, don't I? Multiply by 6, multiply by 6, multiply by 6, multiply by 6. Gone, 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 gone. A is greater than 6, or A is less than -6. Now I can do an intermediate graph. Let's do that right here. I have -6. I have +6. We have open points because we cannot be equal to them. There's no equal to sign. This is saying anything A is greater than 6, so to the right of 6. And this is saying A is less than -6, so to the left of -6. And with these, it's kind of interesting. For 21, 22, and 23, you get to choose the word and or. In this case, I want this solution. The way that I make that solution is with the word and. If I had or. Correct answer here is or. So it's going to be this one or that one. If you forget to use the words or and, I have to take off points. Although I think in the actual final that you guys will be taking at the end of the year in December, you will be having some multiple choice, and it doesn't matter that much. But make sure you have that word in the actual free response test. And there's the graph, which I guess I'll do it again up here. Between -6 and +6, going like that. All right, in number 22, again, absolute value we want to isolate, so get rid of this 8, add the 8, and we have absolute value of negative 10 minus 8m, and absolute value is greater than 14. From there, we're going to drop the absolute value. We're going to get negative 10 minus 8m and negative 10 minus 8m. The only thing that's going to change, we're going to strictly have greater than 14 first, greater than 14. And the other one, we multiply everything on the outside by negative 1 and essentially flip this to a less than from a greater than, and now a negative 14. We're going to solve each of these the exact same way. Add 10, add 10, add 10, add 10, and those are going to go away. Negative 8m is now greater than 24. Over here, we'll have something different, and negative 8m is less than negative 4. And then finally, divide by negative 8, divide by negative 8, divide by negative 8, divide by negative 8, and those are gone. Okay, be careful. We divide by negative. Anytime you multiply or divide by negative, these signs switch. This is now a less than negative 3. The sign also switches. This is m now greater than 1/2. So let's do an intermediate graph before we do our final graph, just in case we need to make some revisions. We have a negative 3 right here. We'll have a positive 1/2 right there. Open points at each of them because we cannot be equal to. We don't have the equal to sign. This is saying m is less than negative 3, so we're going to the left. And this is saying m is greater than 1/2, which means we're going to the right. And again, this is that intermediate function, which means if that's the function that we have. We don't need to change it. Because we don't want overlap. If I had some sort of graph like this, that the only way to make that graph is with overlap, and the word must be and, but since we have the opposite of that, it's going to be or. We just have no overlap. None of those lines are on top of each other. The correct answer here is or. And then I can graph that final answer up here. I have a negative 3, go to the left, and I have a positive 1/2, which lives right about there, and going to the right. And finally, number 23. Again, isolate the absolute value. Be careful here. Many people make the mistake of saying 10 minus 6 is 4. Don't do that. This 6 is trying to be distributed in here, but you can't distribute into absolute value. So instead, you're just forced to get rid of it by subtracting 10. Subtracting 10, subtracting 10. And you get negative 6 times the absolute value of negative m minus 7, and absolute value is greater than negative 90 now. From there, we're going to divide by negative 6, divide by negative 6, you're gone. Now we're going to say the absolute value of negative m minus 7, and absolute value, oh look, we multiplied or divided by a negative, so the sign will switch to a less than, and I'm going to do negative divided by negative, which is a positive. I'm not sure how to do 90 divided by 6. I have a feeling the answer is 15. I'm going to preemptively write that, but let's go ahead and see if I can check that. So I know that this is kind of the way that my brain worked. I saw this as 60 plus 30 as 90, and divide each of those by 6. This is going to be 10, that's going to be 5, 10 plus 5 is 15. So indeed, the answer is 15. All right, from here, we're going to drop the absolute value symbol and turn this into two different equations. The first equation is going to be negative m minus 7 is less than 15. The other equation is negative m minus 7 is greater than negative 15. Again, notice I switched the sign and switched the, or I guess that's the sign, yeah. The inequality symbol was switched direction, and I switched this to a negative, the opposite, right? And then solve each of these the same way. We add 7 to everything, add 7, add 7, add 7, add 7. Negative m is going to be less than 22, and negative m is going to be greater than negative 8. And then divide each of these by negative 1. So, oh my goodness, divide by negative 1. Or I guess I could multiply by negative 1 too, couldn't I? I could say multiply by negative 1, multiply by negative 1, multiply by negative 1, multiply by negative 1. You can multiply or divide by negative 1. It doesn't really matter. Negatives will cancel out, negatives will cancel out, and m is going to be, okay, look, we multiplied or divided by negative, so the sign yet again switches to a greater than, and I have a 22 that's negative. This one's going to be an m, switch the sign from a greater than to a less than. Negative 8 times negative 1 is a positive 8. And let's graph our intermediate answer. We have a negative 22 over here. We have a positive 8 over here. Both of them are open, and we want to be greater than negative 22. So greater than means I'm going to the right of 22. And we want to be less than 8. So we're going to be less than 8. We want to have this overlap area. Otherwise, the answer will be all solutions because this goes on forever. This goes on forever. If I said the word or, then it's everything. I only want this in-between area. So the correct word here that you're looking for is the word and whenever you're trying to get in-between values. And here's the final answer between negative 22, open point here at negative 22, and 8. And we want all values in between those two numbers. We don't want anything over here or over here. All right, one additional thing that I forgot to mention in this video, we had a lot of absolute value equations with 21, 22, and 23, as well as from before with, where were they? Over here, 12, 13, and 14. If you ever get something like absolute value of I don't care, and it's somehow equaling a negative, or for some reason it's less than 0, which is kind of the same thing. A negative is the same thing as less than 0. That is impossible, and if that ever happens, stop what you're doing and just say no solutions. All right, that didn't happen in our case, but I have a feeling that might happen on the test or the final, so be ready for that. And I think that's all I've got for you guys. So I'm going to go through each of these pages and make sure you have everything. So there's the last page, second to last page. You know what these are. That concludes practice test 1 for Algebra 2. Thank you for watching.